Welcome to another session of Grade 9 Mathematics, Chapter 12, Polynomials. Dear students, in this sixth part of the chapter, we shall start discussing about algebraic identities, understand them, and then apply the algebraic identities to solve the sums of NCERT exercise 2.5, question number 1 to question number 3. Let's first understand the different algebraic identities. Now, these algebraic identities are extremely important for grade 10 also. So please pay attention and learn it thoroughly, the different algebraic identities. So, there are 9 basic algebraic identities that you should be aware of. The first algebraic identity that you must have also learned in your previous grades is something called a plus b the whole square, which is equal to a square plus 2ab plus b square. The next identity is a minus b the whole square, which is equal to a square minus 2ab plus b square. You must also have come across this particular identity in your previous grade, and that is a squared minus b squared, which is equal to a plus b into a minus b. Apart from that, in grade 9, you'll also learn the cube of a polynomial, the algebraic identity associated with the cubes of a binomial. So the first one is a plus b the whole cube, which is equal to a cube plus 3a square b plus 3ab square plus b cube. The next one is a minus b the whole cube, which is equal to a cube minus 3a square b plus 3ab square minus b cube. We'll also learn in grade 9 how to use the next identity, which is a plus b plus c the whole square, which is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Towards the end of the chapter, you learn how to use the next identity, which is a cube plus b cube, which is equal to a plus b into a square minus ab plus b square. Also, we shall be using the identity a cube minus b cube, which is equal to a minus b, a square plus ab plus b square. Apart from this, we shall also use an identity which we have learned in our previous grades, and that was x plus a into x plus b, wherein which is equal to x squared plus a plus b into x plus ab. So, dear students, please ensure that you learn all these 9 different algebraic identities thoroughly. There are identities that we'll be using apart from these 9 also. We'll come across that when we solve sums associated with those identities. I hope you can thoroughly learn these identities and then apply the same in solving NCERT exercise 2.5. Let's try to solve the first question of NCERT exercise 2.5. Now, in a textbook, the first question of exercise 2.5 is use suitable identities to find the following products. Now, as you could see, the first question is x plus 4 into x plus 10. What is it? X plus 4 into x plus 10. Now, you may realize that here the first term in both the brackets are the same. But then what is different is the second term. So as I mentioned over here on the right hand side, the identity that we shall be using is x plus a into x plus b, which is equal to x square plus x into a plus b plus ab. Okay, so all that I'll be doing is replace the value of x, a and b in this given identity. So how shall it look like? X the whole square plus x, what is a? A is 4 plus what is b? B is 10. So 4 plus 10 plus AB. AB means A into B, that is 4 into 10. So which when solve gives you x square plus 14x plus 40. Yes, let us try to do one more sum and then have a further and a better understanding. The question is x plus 8 into x minus 10. Now, over here again, you will realize that the first term in both the brackets is the same. What is different is the second term. In the first bracket, it is plus 8, and in the second bracket, it is minus 10. So, which identity shall we use? Yes, the same identity, which is x plus a into x plus b. Okay, so what is x over here? It is x itself. What does a stand for? Plus 8. What does b stand for? Minus 10. Then all that we have to do is replace the value of x, a and b in the identity. So once you do that, you'll get the final answer as x squared minus 2x minus 80. I hope you're clear with the second question of exercise 2.5. Now, let's do the third one. Here, the question is 3x plus 4 into 3x minus 5. Yes, over here again too, the first term is the same. What is different is the second term. What is the second term? In the first bracket, it is plus 4, and in the second bracket, it is minus 5. So which identity, when you have got the first term same and the second term different? Yes, the identity would be x plus a into x plus b. What is x replaced by? Yes, x will be replaced by 3x. What will a be replaced by? Yes, a will be replaced by plus 4. And what will b be replaced by? B will be replaced by minus 5. So all that we have to do is replace the value of x, a and b and then solve it further. And you will realize that the answer is 9x squared minus 3x minus 20. Let me take you to the fifth question, which is 3 minus 2x into 3 plus 2x. Let us observe the terms. The first term is the same for both the brackets. Even the second term is also same for both the brackets. So you have got the first and the second term, which is exactly the same for both the brackets. But then first term has minus, that is 3 minus 2x, and the second term has 3 plus 2x. So which identity shall come into play? Yes, a minus b into a plus b, which is actually equal to a square minus b square. So what will my a be replaced by? A will be replaced by 3, and what will b be replaced by? B will be replaced by 2x. Is that clear? Yes. So if that's the case, then let us get into question number 5. Now, question number 4. 5 was already discussed. This is question number 4. You'll find here the question is y square plus 3 upon 2 into y square minus 3 upon 2. The first and the second term is the same in both the brackets. What is different is the sign. The first bracket has got a positive sign, that is y square plus 3 by 2. And the second bracket has got a negative sign, that is y square minus 3 by 2. Yes. So when you have got both the terms to be same and the difference is only the sign, which identity? Yes, a plus b into a minus b is equal to a square minus b square. So what will a be replaced by? A will be replaced by y square and b will be replaced by 3 by 2. So you must have observed in the last 5 questions that we discussed that what is important for us to solve the sum is to identify which identity need to be applied. Yeah, what is important is to understand which algebraic identity has to be applied to solve the given question. So once you understand that, then it's all about putting the values in the algebraic formulas. I hope that's question number 1 of exercise 2.5 is clear to everyone. If that's the case, let me take you to question number 2. Question number 2 says, evaluate the following products without multiplying directly. So I have to find the answer, but I'm not supposed to multiply them directly. So what is the first question? 103, that is 103 into 107. Now, I can use different identities, yes, to solve this particular question. Now, what I've done over here is, I have written 103 as 100 plus 3 in the brackets and 107 as 100 plus 7. Now, once I rewrite the question in this format, that is 100 plus 3 into 100 plus 7, you'll realize that the first term in both the brackets is the same, but the second term is different. So, which identity shall come into play? Yes, x plus a into x plus b is equal to x square plus x into a plus b plus ab. And then all that I did is replace the value of x by 100, replace the value of a by 3, and replace the value of b by 7. The final answer that I'm getting over here is 11,021. That is 11021. 11,021. Yes. So what we did over here is we just rewrote the question in the form of an algebraic identity so that we can relate to that particular identity and then solve it further. Likewise, the second one. The second question is 95 into 96. Now, 95 can also be written as 100 minus 5 and 96 can also be written as 100 minus 4. You can solve it that way too. But then what I did over here is 95 is written as 90 plus 5 and 96 is written as 90 plus 6. So the first term is same in both the brackets, the second term is different. So here comes our identity x plus a into x plus b. What does x be replaced by? X shall be replaced by 90. What should a be replaced by? A shall be replaced by 5. And what should b be replaced by? B should be replaced by x. So when I replace the values of x, a and b, the final answer that I'm getting is 9,120. Dear students, please ensure that when you calculate the sums, you get the answers correctly. I hope the solution to this second question was also clear to you all. If yes, let's solve the next question. That is question number 3 of question number 2. 104, that is 104 into 96. Now, I can use the identity x plus a into x plus b. Yes, I can write 104 as 90 plus 14 and 96 as 90 plus 6. I repeat again, I can write it as 90 plus 14 into 90 plus 6. But then at the same time, I can also write 104 as 100 plus 4 and 96 as 100 minus 4. Now, if you could see, once I write it in that form, the first and the second term for both the brackets remains the same. But then there is a change in sign. So which identity shall come into play? Yes, a minus b into a plus b, which is a square minus b square. All that you have to do is replace the value of a and b. So instead of a, I'll write 100. Instead of b, I'll write 4. And then solve it further. So a square minus b square. So that is 100 square minus 4 square. 100 square is 10,000. 10,000 minus 4 square is 16. So 10,000 minus 16, which happens to be 9984. That is 9,984. See how you can actually get the answer of 104 into 96 even without multiplication. Isn't it interesting? Yes. Now let's do the question number 3 of exercise 2.5. Question number 3 of exercise 2.5 asks us to factorize the following using appropriate identities. Now, the first question, if you could observe, says 9x squared plus 6xy plus y squared. Now, if you must have paid attention in the previous sessions, you would realize that I had said something of this sort. That bacha, whenever we have three terms, let's go for middle term splitting. But you will also have noticed that over there in those quadratic or cubic equations, yes, what we had is three terms. Yes, but then the first or the second term was not a perfect square. Whereas over here you will realize that the first and the third term is a perfect square. Yes or no? Yes. 9x square can be referred as square of 3x. Y square can be referred as square of y. So when you have got three terms and wherein the first and the last term are perfect squares, you will use the identity a plus b the whole square or a minus b the whole square. So let us solve this sum. The question is 9x squared plus 6xy plus y squared. Now, you realize that 9x squared can be written as 3x the whole square. Now come to the last term. Y squared can be written as y the whole square. Now, if I try to just put the values, yeah, let me consider that it is an identity of a plus b the whole square, that is a square plus 2ab plus b square, and I just put the value of 2ab, that is 2 into a is 3x and b is y, that is 2 into 3x into y. Hello, I'm getting 6xy, which is what I have to have my middle term as. So it clearly states, the second line clearly states that the given polynomial is actually of the form a square plus 2ab plus b square. So which is actually a plus b the whole square? Yes. So I shall factorize it and write it is 3x plus y the whole square. I hope this is now clear to all of you. Let's understand it further by doing the second sum. 4y squared minus 4y plus 1. What's the first thing that you shall do? Identify if the first and the last term are perfect squares or not. Over here, you will find that the first term, which is 4y squared, is a perfect square of 2y. Yeah, 2y the whole square. And the third term 1 is a square of 1 itself. Yes, so the first and the last term are perfect squares. So which identity shall come into play? Either a plus b the whole square or a minus b the whole square. But then you will realize that the question is 4y square minus 4y plus y. It has got a minus 4y. So which is very similar to the second identity. That is a minus b the whole square is equal to a square minus 2ab plus b square. So that's what I've tried to do over here also. 4y square is written as 2y the whole square. And going to the last term, 1 is written as plus 1 the whole square. And then I've just tried to represent 2ab by putting the value of a and b, which clearly indicates to me that this particular polynomial is very similar to the identity a square minus 2ab plus b square. Hence, I can simplify and write it as a minus b the whole square, which is a is 2y, so 2y minus b is 1. So 2y minus 1 the whole square. Now let us do the third question. Factorize the following using appropriate identities. Very similar to the first two also, wherein we are supposed to factorize. Yes. And over here, you will realize the question is x squared minus y squared upon 100. So how many terms are there? Two terms. Now try to recall the identities that we discussed in the very first step. Which identity shall come into play? Isn't it very similar to a square minus b square? That is the difference of the polynomials. Yes. So x square can be written as x the whole square minus y square upon 100 can be written as y upon 10 the whole square. So what did we write? X the whole square minus y upon 10 the whole square. Which identity does it resemble to? It resembles to a square minus b square. What is a square minus b square? It is a minus b into a plus b. That is x minus y upon 10 into x plus y upon 10. I hope the solution to this third question is clear to everyone. So dear students, with this we come to the end of this part. Hope you have understood the application of different algebraic identities as of now to solve different sums given in your NCERT exercise. Practice this well. This is all for now. Take care of yourself until we meet next time with another session. Thank you.